What is conservation chemistry? I know what conservation biology is, but I don't know if a chemist can do it. I know that conservation works. Bald eagles, humpback whales, they were nearly extinct, but I've seen them in the wild. It's because of actions from conservationists before I was born. I've always wanted to plug into conservation, but I wasn't sure how. I'm a chemist. In my worldview, everything is atoms and bonds, reactions that smash together chemical building blocks to make the medicines of the future. I've enjoyed a career in big pharma, in biotech, and now in academia. I've worked in Alzheimer's, diabetes, hypertension, cancer, and infectious diseases. I've seen a transformation of the speed with which we can invent medicines, spurred on first by genomics, then by robotics, and today by artificial intelligence. We live in a golden era of medicine. So when I learned that cancer is the primary reason sea turtles strand on the beach in America today, I was shocked. Last year I met Bellatrix, a sea turtle just riddled in tumors. For a creature in this condition, there's really few options other than surgery. But in the pharmacy, we have hundreds of cancer drugs today. Surely one of them could be helpful to Bellatrix and sea turtles like her. I run a drug discovery lab where we try to find proteins inside the tumors of sea turtles like Bellatrix and match winning cancer drugs to them in hopes that we can improve this condition. But with all the changes that are happening in our world today, it's not just sea turtles. Sadly, we lost 98% of elephant seals in Argentina last year to avian flu. The state tree of Pennsylvania, the majestic hemlock, is in a battle against an invasive insect and it's not winning. The greatest pandemic this planet has ever known is a fungal infection called chytrid. It has driven the extinction of hundreds of amphibians already. I'm a chemist who has dedicated my life to improving health, and I cannot look away from these diseases. I needed to do something about it. When I met Pebbles, the Gila monster, she had already lost 30% of her body weight. She was infected with a parasite called Cryptosporidium, and for a reptile, crypto is basically a death sentence. There's no treatment. And yet, you know those diabetes and obesity drugs you keep hearing about in the news? The first one came from the saliva of a Gila monster. How is it that we built a multi-billion-dollar pharmaceutical empire on the biology of this animal, but for Pebbles there was nothing? My lab hopped into action, and from the Creature Conservancy, a wildlife rescue center that cares for Pebbles, we received a very generous gift of Gila monster poop. And from it, extracted the parasite that I show here. This is the first electron micrograph of Cryptosporidium varanii. And we were shocked. You can see that it's got this really thick black ring coating it in a layer of protection. And outside of that, there's an additional jelly protectant. You cannot kill this parasite with bleach. Pebbles' body weight just kept going down. So we needed to do something. My lab built an AI agent that could hunt through the entire medicinal literature, trying to find a molecule that might be relevant to this situation. And the one that popped out was called pyromomycin. In the lab, we mixed this chemical with the parasite in a test tube and obtained this image. And as you can see, we have abused this bug. Its protective layer is dissolving, its insides are exploding. Within days, the Creature Conservancy started Pebbles on a treatment of pyromomycin. And I'm very happy to report that following the treatment, she tested negative for the disease. She stopped regurgitating her food and regained her appetite and vigor, and has since put on most of the body weight she lost. Thank you. This moment convinced me. Chemists can be first responders in the fight against extinction. Today, we can make precision health products at a rapid pace. And you might be thinking, isn't it habitat loss and poaching that drives extinction? You're also correct. But we can no longer look away from disease as a driver in biodiversity loss. In my lab today, we're inventing precision treatments for bald eagles with avian flu, to tackle the sap-sucking insect that is killing the state tree of Pennsylvania, and precision antifungals for endangered frogs and other related species in need. Just as conservationists from before my time brought back rhinos, pandas, and humpbacks, it is my hope that conservation chemists can unite for ecosystem health. I know chemists who've invented drugs for all kinds of diseases. Let us now turn our attention to those who need it most. Thank you.